Welcome. This is 7.2, multiplying exponents containing, or expressions with exponents. All right, so now we're going to see what happens if we have two bases and two exponents and we're multiplying them. So if you look at all these examples, we have exponents and we have variables and they're being multiplied by each other. All right, so let's start by first expanding and seeing what happens. So we know that x to the third is the same as x times x times x. And x squared is the same as x times x. So if we were to combine these, how many x's do we have? So there'd be 5, right? So we'd get x to the fifth. All right, so here's another example. This would be y times itself 4 times, and then we're going to multiply it by x to the third, which is y 3 times. Okay, so if we were to simplify that, that would give us, we add all those up, there's 7 of them, so that'd be y to the 7th. So what is the pattern that we see here? What happens if we're multiplying like bases? What do we do with their exponents? Well, it looks like we just add them together. Okay, so let's see if that applies here. So x times x squared. Oh, but I don't see an exponent on the x. So if we were to expand it, well, that's just 1x, and then we have x and x. Well, that would give us x to the third. Oh, so what must this exponent be? It's got to be a 1. So if we don't see an exponent, it's going to be a 1. All right? So there we can just add those together, and we would get x to the third. So it's really quick. You don't even need to expand, but that's just kind of the way we used it to kind of figure it out. Okay. Here's another example. So just remember that this negative isn't part of the base. It has a coefficient of -1. So coefficients, we do just what they normally do. So here it has a -1, here we have would be like a coefficient of 1. We just multiply them like normal. So -1 times 1 gives us -1. And then here we've got our x and our bases and our exponents. So x to the fourth times x to the fourth. Again, if they're being multiplied, if we multiply the bases, we'll just add those exponents. So that's just x to the 8th. Okay? So here's another example. Why don't you give that a try? Just remember coefficients. We just multiply them like normal. And then if we're multiplying like bases, oh, those aren't like bases, so that's something we should talk about. Okay. Y squared and x to the fifth, we can't combine those because they're not like terms. Okay. We can do the -3 and the 2. That gives us the -6. But then we would still have the y squared and the x to the fifth because we can't, they have to have the same base. Okay. Why don't you give this one a try? All right, so hopefully you multiplied the 5 and the 2. That gives you 10. Multiply them like normal. And then this is like an x to the 1. So x to the 1 times x to the 2. Again, we just multiply those, add those exponents. So we'd get x to the third. All right, so what's the rule? Okay, when we multiply like bases, we add their exponents. Okay, kind of like an example of that, like a generic example would be like if you have x to the a, where a could be any number, and times x to the b, where b is another number. So that is the same as x to the a plus b. We just add their exponents. You're probably going to want to memorize the rule. You don't have to memorize it word for word like that, but being able to know what we do if we're multiplying like bases. Okay? So once you have that done, you can do it really quick. Okay? You don't need to expand. You can if you'd like. You could rewrite this out and do y 2 times and then y 4 times, and then realize we have y to the 6th. or we could just add those. So let's do 3 together without expanding. All right, one thing we should notice though is if we have negative exponents, we can't expand, okay? You can move it up or down. Like if you wanted to expand, you would need to move this to the bottom. And we talked about that last time. So this is the same as x to the 5th over and then x to the positive 3. So you could do that, okay? But it's really easy if we just use the rule. So like bases, they're being multiplied, so we'll just add those together, okay? So that would be x to the, what's negative 3 plus 5? Well, that's just 2. Check. All right, here's some other examples. Feel free anytime to pause. Okay, like bases, they're being multiplied, so we're going to add their exponents. So that would be x to the 5 plus a negative 2. Maybe I'll bring it up. Okay. If you're not sure what that is, you can always plug that into your calculator, but 5 plus a negative 2 is the same as 5 minus 2, which is x to the 3rd. Okay. All right, let's do 4. Again, coefficients, these do not have exponents on them. We multiply them like normal, so that's 10. And then these are like bases. They are being multiplied, so we will add them. So that's x to the positive 9. All right, why don't you give a try on these two? Again, coefficients, we multiply them like normal. So negative 3 times 2 times 5. So that would give us, what, that's negative 6 times 5, which is negative 30. And then our like bases, again, this is like an x to the 1. We're going to add all of those exponents. Oops, sorry. So that would be 3 plus 1 plus 0. So that would give us x to the 4th. Okay? You could also say x to the 0 is just 1. You can do that as well if you preferred. Okay? All right, hopefully you gave this one a try as well. So coefficients, we have a 2 and a 3. We multiply them like normal, so 6. We will look at like bases, so x's. This is x to the 1 and x to the 2. So that would, we add those, and x to the 3. And then we'll look at the y's, and that would give us y to the 5th. All right, here's just some other examples if you'd like, or you can kind of skip it if you need to. This would be x to the 1 plus 3 plus 5. Probably should do that more often, writing them like that. But that would give us x to the 9th. Here we have some coefficients. This would be like a coefficient of 1 if you wanted to put that there. We multiply those together. So 4 times 1 is 4, and 4 times 6 is 24. And then we will collect all of the x's, and we're going to add their exponents. So that's like x to the 6 plus a negative 2 plus a negative 3. Okay, and again, that's the same as 6 minus 2 minus 3, which is 1. So 24x to the 1, but x to the 1 is just x. Okay. All right, next, or I guess the last thing we need to talk about is kind of like area. You talked about area before. Area is length times width. Okay, so this is like your length, this is your width. This could be your length, and this could be your width. It doesn't really matter which is the length, which is the width. But if we're trying to find the area, is we're just going to multiply the length and the width. So area is equal to 4x squared, and we're going to multiply it by, I guess we probably don't need the parenthesis, times 3x to the 3rd. So now it's just like a problem we did above. Okay? So 4 times 3 is 12. And then we have like bases. We're going to add their exponents, x to the 5th. Why don't you give this last one a try and see what you get? So A is equal to length times width. So x squared y times x squared y to the fourth. And we combine like bases, so that'd be x to the fourth. And then here we've got y to the fifth. All right, if you have any questions, just let me know. I'd love to help you out. We'll see you later.